Assalamu alaikum everyone, I'm Samir Rafiq along with my team, and we are here for the research presentation on EEG based mouse cursor control using motor imagery based brain computer interface. An MI BCI is motor imagery based brain computer interface, where MI is a mental execution of affected body part without even performing to move that body part, and BCI is an intentional interface that allows a user to control the computer or external devices using the brain activity. An EEG is electroencephalogram, and if you break it down, then it stands for electrical brain picture, which is a representation of recording of the brain's spontaneous electrical activity over a period of time. It's a non-invasive technique to record the brain's activity, and the test is done by using small metal discs, which are known as electrodes. According to the WHO, approximately 1 billion of people are suffering from various kinds of disabilities, which include stroke, paralysis, paresis, and congenital limb disorder. So our project is driven by a deep-seated motivation to create an alternate method to control the computers for those who have completely lost their upper limb mobility. So far, we have done an ample amount of literature review, and we have observed the major problems that in most cases they have only focused on the classification over implementation, as well as a limited number of systems implemented an interface to control something in real time. So we aim to record the MI BCI based EG data, as well as to implement the data to control the mouse cursor in real time. Moving to the methodology, this is the methodology that we have focused on our project. Moving to the proposed system, we in data acquisition part, we have recorded the raw data using the wireless headset 14 channel motive epoch named, and after that we went for the segmentation, and in the filtration part we have used a butterworth filter to remove the unwanted noises, and then we have extracted the feature from the filtered data. And moving to the classification part, we have used the SVM or Suffolk vector machine to classify the extracted features data. And lastly, in the implementation part, we use the MATLAB so that we can be able to create the algorithm to move the mouse cursor. In the system design part, we have created a video so that we can be able to give the command to the volunteer for our data acquisition part. We have segmented into 10-second small chunks the raw data, and after that we went for the filtration so that we can be able to move the unwanted noises. Moving to the performance evaluation parameter, we have used a five-fold cross validation as well as the confusion matrix so that we can be able to show the sensitivity, specificity, precision, and accuracy performance parameters. In the resultant analysis, we have shown the minimum accuracy to the maximum accuracy, as well as the ROC and AVC curve for different frequency bands, where we have achieved the highest accuracy for the gamma is 93%. We have also shown the system latency, where the from the data loading part to the single movement part, which the time has been taken is 1 minute and 29 seconds. So moving to the investigation part, in this mouse cursor control using revised algorithm, here you can see the cursor is moving to the right as the volunteer uh, has been commanded to think the cursor is moving to the right. And when the volunteer was not even thinking or doing the rest, the cursor will be performed the click. All the work is done by using the MATLAB software, and we have created the algorithm by our own so that we can be able to move the mouse cursor. So moving to the ethical factor, the social impact that reduce the inequality faced by the physically challenged people in the society, as well as the health and safety issue. All the IEEE standards are met, as well as the EG data collection is FDA approved, as well as in the legal and cultural issue, there is no cultural impact, as well as the EG signal do not collect any personal informations. Moving to the environment and sustainability in the impact of the project, we have observe the 4 points, where the three number 3 is good health and well-being, number 8 is decent work and economic growth, number 9 is industry innovation and infrastructure, and number 10 is reduce the inequality. And this is the overall budget, that 22,700 only, that has been implemented in our project. And so moving to the conclusion, we have successfully created the classification model, and as well as we have implemented in offline, we have achieved the highest accuracy, which is 93.78%, as well as we have created a model for the mouse cursor so that we can be able to move the cursor. So thank you so much.